Okay, so we're going to do types of radiation, homework 6.5. And the first question, radioactive carbon-14 is an isotope of carbon. Let's just zoom in on this. It says it is produced high in the atmosphere when a neutron combines with a nitrogen nucleus. Okay, so what's the question asking us? Write down carbon-12 in the form AZX. So as you can see, if carbon-14 is written down in the form AZX, where 14 is the mass number, A, 6 is Z, which is the atomic number, the number of protons, and then X is replaced by the symbol of the element. To write that carbon-12 meaning that it's got a mass number of 12, it is simply C12, and then it's got the same number of protons. An isotope will always have the same atomic mass, so it's always going to be 6. Just the top number changes. Remember that top number is the number of protons and neutrons, and to find out how many protons, you just take this from that to find out how many neutrons you have. So in this case, it's got 6 neutrons, whereas this little fella has got 8 neutrons. 14 minus 6 is 8. The nuclear reaction that produces carbon-14 is written below. Now, this is not a nuclear equation. This is you just identifying. So in maths, we use an equals sign. In science, we can use this arrow to represent this is the same as that. So whatever this is the same as that when we balance equations. So if I've got, let's start with the bottom row. So I got a 0 plus 7 must be equal to 6 plus something, which is 1. So 6 plus 1 gives us 7. 0 plus 7 gives us 7. Now we can do the top. If we look at this side, 14 plus 1 is going to add up to 15. 1 plus something must add up to 15 as well. So that 1 plus 14 must add up to 15 there. Okay, for 2 marks that is. Then it says complete the following sentences. So this one caught me out. Complete the following sentence with the number of particles, if any, in a 1416C nucleus. So that's an isotope of carbon there with mass number 14. So it's going to have 6 protons in the nucleus. So there it is. It's in bold. It's going to have 8 neutrons in the nucleus, 14 minus 6. So for the big number, the small number minus the big number. By the way, the big number is sometimes on the bottom, the small number is on top. You just got to watch. And then the first time I did this, I put 6 because I didn't really read the question. I thought if it's got 6 protons, it's bound to have 6 electrons. But you don't find electrons in the nucleus. So I was wrong there. So it's 0 electrons are always going to be found in the nucleus because electrons are found in electron shells around the nucleus, flying about. It says iodine 131, so that means it's got a mass number 131, is present in fission products of uranium. It is a beta emitter with a half-life of 8 days. When absorbed into the body, it concentrates in the thyroid gland, increasing the risk of thyroid cancer. After the nuclear disaster in Japan, people living in the area were given non-radioactive iodine. Supplement tablets to reduce the iodine 131 that leaked into the reactor. So the first question, what is a beta particle? Well, it's a fast-moving electron. Okay, so you can take a punt at fast-moving particle, but electron is the top answer there. It's a fast-moving electron. Explain why iodine 131 increases the risk of thyroid cancer. Well, it's radioactive, and when you've got a substance that's radioactive, it's very ionizing. Ionizing means that it's able to break molecules down into ions, because it's either going to be an electron or it's going to be a positive protons and neutrons in the case of alpha decay. It can come into contact with your cells, damage your cells by stripping either the electrons or picking up those protons, depending on what it is. So then those cells become ions, and they can take place in chemical reactions in your body that you might not want it to take place. So they can mutate cells as well. So ionizing and radioactive are your 2 marks there. Then it says compare the nuclear structure, and then just the nucleus really, nuclear structure of iodine 131 and iodine 127. That is there. So I've said they're both isotopes. They both have the same number of protons, which is 53. That makes them the same element. If you looked at the periodic table, iodine would have a small number of 53. They do have a different mass number, so you've got 131, 127, which means that 131 has 4 more neutrons than 127 there. And that's for my 3 marks. And then the final page, let's zoom right in on this. It says, radioactive waste is dangerous to the public. Waste has been disposed of safely. Explain why radioactive waste is dangerous to people. Well, it emits radiation, which is, again, ionizing, damages cells, causes mutations. Okay, you're going to get the 2 marks with that. Give a reason why not sending the waste into space is viable. Give 2 reasons why not sending the waste into space in rockets. Oh, right, I see. It's expensive, and there's a danger of an explosion during takeoff. So if, not only would you lose the rocket, you would contaminate that area as well, which isn't good. So that's why they don't do it. And it's really expensive. Radioactive waste can be buried underground. State why you need to be monitored. Well, it takes thousands and thousands and thousands of years for some of these elements to decay. They've got a long half-life. We haven't done half-life yet, but that is I think it's worth 2 marks, is it? No, it's only worth 1 mark, so you'll get the mark with it takes many years to decay. State the danger of storing waste underground. Well, if there's an earthquake, it can leak, and then it can contaminate that water and the soil surrounding that area. So, still not brilliant. And that's the end of that paper.